National Society of Black Engineers. So what we have today is we're going to do a couple pretty cool demonstrations for you guys. Just sit back. I'm John.
My name is Luciano.
I'm Liam.
I'm George.
I'm Karen.
And that's Swan. So first thing we got today is who likes ice cream? All right, pretty good. Popular says. So the thing with ice cream is you make it homemade. It takes a while. It takes a pretty long time. You have to freeze it before. You have to do that.
You got to churn it.
You got to churn it if you do it conventionally. So today, doing other things a little unorthodox. Right here we have the ice cream base of science. Pour that in the bowl there. It's just, you know, half and half cream, sugar, a little bit of vanilla, real basic. Stir that around a little bit. And now we add the cold. So today we're going to use the advantages that we get from a couple gas laws to make ice cream with this fire extinguisher. It's a pretty easy thing. So the gas laws, there are three main ones that you really have to, that really come into play here. One is called Boyle's Law, which just says that the volume and the pressure of the gas is proportionally inverse of one another. Then we have Gay-Lussac, which is the pressure and the temperature is directly proportional. And we have the combined gas law. That's a combination of the two. So you put it together to get the combined gas law. Now what happens here is, and right here it's CO2 under very high pressure and liquid form. Now what we're doing here is, because the pressure is decreasing so rapidly, temperature is also decreasing, actually turning into solid. So what we're going to get is a lot of dry ice. Now the dry ice, then we just mix it together, and with that, and we get ice cream. Not done yet.
Slowly. Put that in now.
So I should actually probably time this to compare with how long it actually takes to make ice cream normally. So the interesting with this is, now fire extinguishers come in a couple flavors. For this one to actually work, you specifically need CO2. Other ones are chemical, water-based. Chemical-based and water, well, water will just make it watery, chemical-based just make it disgusting. And there we go. So, someone could be so kind as to help me pour this in while I stir. Got a pretty nice.
Do you want gloves?
I got it. I got it. Oh yeah, that actually causes frostbite. You can actually see it's already frozen up top there. So the part is thank you. The tricky part is to kind of place it slowly, because what we're doing is we're actually making ice cream by the act of boiling, which is odd enough. The first time we tried this, it kind of boiled all over the place and made a big mess. I don't think.
If you guys can't see, you might want to come up here and look at this, because
Yeah, it's
awesome.
actually. You can actually
boil
see
ice cream.
yeah, you can stand up.
You can
Keep that going. I have to stop and stir this a bit.
Sorry.
Darren wants to know, if you break a gas law, do they lock you up?
I think you're actually a Nobel Prize.
You know what
There you go.
You know what Cunningham? You don't talk. We don't do stuff like
I don't have
that.
to talk today.
We play with lima beans.
Is that what you guys are growing over here?
Yeah.
This is pretty awesome. I tried to grow lemon beans and they all died.
Oh, see, I did that with like radishes. Lime beans are way better.
Totally, because you just get us.
Do you want the gloves? Because I'm actually not really using them. Here, that one at least to have that. Just try to stir that around a little bit. So what's going on right now is it's just cooling everything down. You can pour a little bit in there. Now, the thing that's why this isn't turning into just one big block of ice is because it's cooling at such a fast temperature that the liquid and the water in the mix actually doesn't have time to crystallize. So normally, I mean, you have a pretty, normally with water and stuff, you have a pretty strong lattice. And you probably pour a little bit more than you want to.
You ever see like the Terminator where they freeze in a second?
We
have a few hours.
No, I mean, I can look it up, no problem right there. So, try to see it a little bit.
Is that cool?
Oh yeah, no, this is really cool stuff. It's not as cool like liquid nitrogen. I mean,
It's going right from the solid to gas because it's so cold and then the air is so
does anyone know what that's called?
Remember from chemistry, what's that called when it goes right from a solid to a gas? For points.
I'll be impressed if somebody knows. I didn't know that till last semester.
No, when it goes right from a solid to a gas.
Jamie, you want to hold it?
Sublimation. I heard it.
Almost.
Sublimation.
Right, sublimation.
I was so going to say that.
Sorry.
So what are you, the pastor? Like, what are you, just handed it to everybody? Oh, super good. My hand feel weird.
Yeah, that's actually, I mean, this is probably one of the only times that you'll see at school, probably the only time you see at school, ice cream made by boiling something.
Right.
Or anywhere else.
You're actually boiling the solid just because the air is so much warmer than it.
Let me stir this a little bit more, try to break some down before we pour some more in because, we're just trying to not have this actually boil over because it does make a massive mess.
Don't do that at home, folks.
I made a good spring.
Can you put that in your beverage and like?
Oh yeah, this is entirely edible. We are going to be passing this out.
It's actually, it's what makes your soda.
It's gonna be the greatest ice cream you've ever eaten.
Yeah, the interesting thing about this is because of the CO2, the ice cream is actually carbonated.
Like soda.
Like soda.
It's gonna be like a
So if you put it in your drink, it would not only be cold, but it would also
Can you eat it by
carbonate.
yourself?
Oh yeah. Oh no, not dry. No, you not dry ice. No, do not eat the dry ice.
It's like, it'd be like licking a pole during the winter.
Pretty much, yeah. It will get stuck to your tongue, and it would not be good. You're gonna have to stir this a bit before we add some more. It's starting to actually. You can see it's starting to chunk it a little bit.
Or how's your lecture?
Lecture is actually pretty much settled out. I mean, was it? No, it's just it's hot for the CO2 because I mean the freezing
At room temperature here, we're all breathing out carbon dioxide, but it's a gas. So if you think about water vapor, right? It's got to be hotter than ice. So this is the difference between ice from carbon dioxide.
How long does it
actually the first time we did this, it just kind of boiled over, so we didn't really time it.
So when that melt, what does it turn into?
You can see it's turned right now into gas, just like coming out of
Yeah, right there.
Because it's so,
Pour some more in there.
like everything will turn into a solid to get colder.
That's tough.
So it's super cold, but it's so warm in here compared to what it takes to freeze
Enough,
that.
right?
It just turns right into gas.
Let me stir a little bit more just to. Okay, yeah, do that.
What temperature would that turn that to a liquid instead of a gas?
I don't know exactly what it is. I know the triple point anyway.
Like,
Ballpark, okay, the triple point, which is where all three states will exist at the same time. The triple point of CO2 is actually minus 69.52 degrees Fahrenheit. So probably around,
like minus 100, something like that, probably.
give or take.
So it could be cold. It would have to be like middle of winter, super Arctic conditions.
It would be colder than Antarctica at night, right?
Yeah, colder than Antarctica. Because I don't think there's any place on Earth where the carbon dioxide ever turns into liquid. So
It's come close. I mean, in Siberia, it rarely gets to minus 40 degrees, and that actually
It doesn't have a liquid phase because some things they boil before they.
it's liquid inside the fire extinguisher. So everything has a solid.
Sorry?
Yes, sir.
Oh no, I've been to some of the football games.
Oh,
So everything has a solid, a liquid, and a gaseous state.
who is teaching?
yes.
Now,
Mr. Belcher? Or no, Mr. You said his son is one of our teachers. His teachers.
We know the three teachers here.
Mr. McLaughlin?
we're good. Puffs more in there.
Doc Lock, yeah. Well, because there's two of them, right? 'Cause it's Tom, Tom and.
And Miss McLaughlin.
Oh, that's right, yeah, because we've got now, she's here. My sister taught an after school program here, and my cousin taught an acting program here. So we're kind of joking that we're taking over
It's
this.
a legacy. It's a legacy. It's,
So you gonna come here too? You gonna teach here too?
I'm doing it right now a little bit, but
put puffs more in there.
Y'all just all time. I just love being teach.
All right, we can actually. We might even, because it's not really boiling anymore, we might be able to quicken up. Yeah, see right now, we got some ice cream. Pretty much like ice cream right there.
I want to be good.
First one to taste.
Yeah.
About to go Bob's.
Such weird.
Gonna let you about to get the blender.
Now, I mean, the thing with the CO2 fire extinguisher is they're used primarily in kitchens and restaurants just because the CO2 doesn't contaminate.
Is the bowl cold, like around it?
Check it out. Yeah, see, you can see the bowl. There's frost developing on the bowl. You can probably pop some more in.
I'm gonna keep one of those in my house if somebody trying to attack me.
This is definitely.
Put that in their mouth.
This is a great experiment that people can actually do at home as long as they have the right fire extinguisher.
when all their teachers are telling you to be safe and whatnot, I've had so many of them tell me the stories about things that they tell you not to do.
Because they
One
did
guy
it
was
first.
telling me just yesterday they'd use these to cool their beer in the army.
Chocolate milk.
It's like house catches on fire, whatever. We've got a cold beer.
Yeah, probably. Actually, it's usually better to for anyone who wants to make ice cream. It's usually better to put any sort of
They're
flavoring.
like whipped cream.
Can't you use
It pretty
chocolate
much
milk?
is. It's like this is. The way this is because I'm stirring it so much and because it's pretty much just like a really interesting soft serve.
So you guys are.
We're gonna be done at 10:55,
Yeah,
right?
we've got like 20 something.
Okay, so we have the ice cream
If
now.
you're done, do you want Karen to start doing
Yeah,
hers?
Karen can start hers. I'll stir this up.
Say I'll make it food.
Well, we're
No,
Make it say.
some
no, I'm the only one making the.
I might say, yeah, y'all might gonna make sense.
So you want to start yours and start passing out ice cream?
Yeah, see, we got a nice mound of ice cream right there. Oh, yeah. Yeah, I mean, really, this is just like making regular ice cream. It's just a matter of you're adding the cold in a different form, pretty much. I mean, normally, you would just put this in the freezer and churn it.
Yeah.
But because it's freezing so rapidly,
Just do it when it's done right.
here we go.
No, do we get to eat?
Oh, yeah.
Try it first, come here.
So I want to try it first. Let me try it first.
Yeah.
Mark, come here, Mark. Let Mark try it.
Scared.
Right, like,
I'll eat it for a breeze. So we all
You got first? All right, guinea pig number 1.
I want to sound.
I dance it.
No, you put my moon.
No. That probably tastes like milk cream. Oh, that's how you know.
I want.
Oh, yeah, I went.
He don't say I want. Ooh, I swear it was down.
All right, I think for time purposes, we're gonna start Karen's in the front. We're gonna bring ice cream around. Everybody wants ice cream.
All right, so
Yeah,
let's
sounds
so
good.
bring it around and we're gonna sit down because we're gonna go right up front now. So let's go sit down.
Yeah, this is okay. That's
Really? You about to see something hot.
Let's go right there.